All right, here's my setup for the wavelength red light lab. You'll see a laser right here. The binder clip is holding down the on button because that's all kind of safety. And then what you see here is you have a slit film. It's called a Cornell slit film, and I have no idea where to buy these. I found them on the internet many years ago. They were $20 a piece. I sprung for like 10 of them. I spent $200 on these things because I thought it was that important. It's an unbelievable price. And they're made out of glass, so I did have one of them crack, thanks to some student at some point. But what you'll see is that there's a certain, all these are different space slits, and the sheet of paper that it comes with tells me what each slit spacing is. So the middle one is the one that's the closest together slit spacing. And so what I do is I just can cast this up on the wall, and I can mark where the little dots are, where the little maxima are, and so here I have m equals 0, that's the 0 order maximum, and then here I'll have m equals 1, m equals 2, m equals 3. So what can I do? For constants, what I can do is I can measure the distance from slits to screen, so from here to the slits, I can measure that as a constant. And then what can I vary? I can vary the m. M number 1, m number 2, m number 3. And then from there I can also measure the distance of that bright spot from the center. So I can take a meter stick, just hold it up here, and measure, okay, so maybe about, looks like 3 centimeters, 6 centimeters. Yeah, that's not perfect. I'm going to try to be a little bit more precise. So let's say that does look like 3 centimeters. That looks like 5.8. And then this next one looks like 8.6 or something like that from the center. So I can write those out, and then I can make a graph of x as a function of m, and the slope of that graph I can use in order to find the wavelength of red light along with my constant, which is the length from slits to screen. Now, the other way you could do this experiment, that was the easiest way, the other way you could do this experiment is to actually change the distance from the slits to the screen. So what you would have is you'd have different L's and different X's, but you'd keep the same order. So for example, what I can do is I can measure the distance from center bright over one bright one, so the m is 1. It's going to be the same number every time, but I can do a distance that is close. Let's see if I can get that to work. I don't know if you're seeing that. Okay, yeah, you see the dots are closer together. Then a distance that's, you know, reasonably, and then maybe a little bit farther. So 3 different L's, 3 different X's. I can make a graph of of x going up and L going to the right, and then that will also be a line, and the slope of that line can help me get the wavelength of red light. And then as an extension, you can try this for different colors, such as green and purple. Those are colors that you can get easily. I was able to get a pack of 3 lasers, red, green, and purple, for $10 on eBay, and I think it's worth having one of those per lab group, basically. It's a very worthwhile cost.